Welcome to Lesson 44 from the book How to Program Effectively in Delphi for AS A-Level Computer Science. Lesson 44 is on anonymous methods which were introduced into Delphi in 2009. As the name suggests, an anonymous method is a procedure or function that does not have a name associated with it. But before we get into the details of anonymous methods and how they're used and why they are relevant and important, we need to go through some basics which relate to functions and functional programming in order to understand how anonymous methods arose and proved to be very, very useful in the context of functional programming and imperative programming in Delphi. Let's start with what is a function. Loosely speaking, a function is a rule that for each element in some set A of inputs, e.g. the set of 4 integer numbers 0, 1, 2 and 3, assigns an output chosen from some set B, say the set of integer numbers from 0 to 9, but without necessarily using every member of B. For example, the function f maps the integer set 0 to 3 to integers chosen from the set 0 to 9 in the following way. 0 is mapped to 0, 1 is mapped to 1, 2 is mapped to 4, 3 is mapped to 9, when the rule is output the square of the input. Let us now consider what is meant by function type. Just as data values, for example 6, 9.1, true, have types, integer, real, boolean, respectively, so do functions. Function types are important because they state what type of argument a function requires and what type of result it will return. A function f, which takes an argument of type A and returns a result of type B, has a function type which is written A maps to B. To state that f has this type, we write f, the name of the function, colon, and then the function type, which is represented as A right arrow B. For example, if we have a square root function, we write the name square root, colon, and then the function type, which consists of the name real, a right directed arrow, followed by the name real. If the function is square, we write the function as square colon, and then the name or identifier for the type of the argument, integer, and then the right directed arrow, and then the name or the identifier for the result type, which is integer in this case. The function name square root applied to an argument of data type real produces a result of data type real. For example, square root of 4.0 maps to 2.0. So function types have a representation, a symbolic representation, which is indicated by specifying the set that the argument is drawn from, a forward or right directed arrow, and then the set from which the result is drawn. Square root 4.0 is an example of function application. What we mean by function application is when we call a function and apply it to its arguments, we have function application. So a function application is when the function is applied to a particular argument, e.g. 6 in square 6. In functional programming languages and in some imperative programming languages, a function is a first-class object. This means that it can appear in expressions, be assigned to a variable, be passed as an argument to another function, be returned as the result of a function call. In Pascal ABC.NET, which is an implementation of Pascal and Object Pascal, the function square colon integer right arrow integer is written as shown in the captured screenshot. Let's take a closer look at this Pascal ABC.NET program. It declares a variable with identifier square at this point here. The data type of this variable is actually a function type. And the function type maps an integer argument to an integer result. The actual detail of what is expected of this function is specified here, again using a similar notation. X is the input parameter, and the output or result, or the calculation, is x multiplied by itself. So when this expression is evaluated, it's going to return the square of the value associated with this parameter x. So we can call square because its type is function, and we can supply an argument 6, which at this point will be bound to this free variable or parameter x. So this evaluation will use the value of 6 for x and should return the value 36, which will then be written out to this output window by WriteLine. So let's run this program and see if we get 36. And indeed we get 36. So we try 4, which I tried earlier before I made this video, and we get the value 16. If I try 2, we get the value 4. If I try the value 100, we get the value of 10,000 as expected. So this is quite important because this is a function type using the notation that I described in the previous slide. So we say that this variable square is of type function type, which maps an integer to an integer, and what it's expected to do is to multiply x by itself. Let's now switch focus to anonymous functions in Delphi. Here is a program that I have already prepared and given the name anonymous method square project 2. This is the Pascal ABC.NET program which I demonstrated in the previous slide, and you recall that this expression here represented a particular function type, integer to integer. So I've got to replicate this type in Delphi. So I use the type definition, t function of integer, and I use the keyword reference, the keyword to, and the keyword function. And then I specify the equivalent of the argument here, or the input here, and the equivalent of the output here as integer data type returned by this function. Notice this function has no name because it's an anonymous function type. Now I need to create the variable square, which I do here with an inline declaration. And I need to specify the type of this variable, and it's a function type. And now I need to specify the business part, which I do matching the template here first of all. And then this is equivalent to this parameter here, and this is how the business part of the function calculates the square of x. So this is known as an anonymous function because it's unnamed. Delphi actually has anonymous functions and anonymous procedures, and it collectively refers to them as anonymous methods because under the hood Delphi creates a temporary class with class methods created from these anonymous functions, or if it's an anonymous procedure. Okay, now we're going to look at function application, and we're going to supply the actual argument 6, and we're going to call the function square. So at this point 6 will be bound to this parameter x here, so that 6 replaces the x here and 6 replaces the x here. So evaluating this expression produces the result 36. Now any function call in Delphi, Delphi creates a variable called result, which we use to return the result. So we're going to assign this 36 to result, so it will actually replace this function call square 6 here, so that WriteLine will write 36 out to the screen. Because in console mode the console window is set up to close when the program finishes, the program, if we didn't have this read line, the program would finish prematurely, and the window the window would close prematurely as the program reaches its end at this point here. By putting this read line after WriteLine square 6, we stop the console window closing prematurely. Now function application is very, very important, and the reason why I've emphasized it, because there's a paradigm called functional programming, in which the programmer merely declares properties of the desired result or the desired rod, but not how to compute it. And the desired result in functional programming is declared as the value of a series of function applications. So what one can do in functional program is one can actually apply a function application to another function application to another function application, etc., etc., to compose function applications in order to achieve the desired result. Now that paradigm, functional programming, is classified as being declarative. A declarative programming is programming where the desired result is specified, but not the steps to achieve that desired result. Whereas Delphi falls into the bracket of being imperative. Delphi is both procedural and object-oriented. They're both imperative paradigms. Because one has to specify the detailed steps, specify the order of those detailed steps that need to be executed to achieve the desired result. But by adding anonymous functions, anonymous methods to Delphi, Delphi extended its paradigm to encompass a little bit of functional programming. Now that is quite important because functional programming is a paradigm which doesn't suffer from side effects, and because it composes functions, it makes it easier to create proof theorems that the desired result can be achieved. It makes it easy to reason about the correctness of a program. Functional programming comes from some theoretical work that was carried out in the theories in the 30s by a researcher called Alonzo Church, who developed a calculus called lambda calculus. And this is an expression in that lambda calculus. That is a very poor substitute for lambda. Alonzo Church used the Greek letter lambda here to say that this is an unnamed function that takes a single argument, which will refer to in general as x, and it maps that to, well, in this case, the square of x. So that is, if you like, the function. And now this is the function application by bracketing this and then following it by 6. This function is applied to 6. Now, Alonzo Church's work was equivalent to the work that Alan Turing carried out on Turing machines. They were both seeking to better understand computation and its limits, and they needed an algebra, if you like, or a system to be able to reason about computations. Lambda calculus ended up being embodied in functional programming languages such as Haskell, ML, Miranda, and so on. And it's now in a beta version of Microsoft's Excel spreadsheet, making this particular implementation of Excel Turing complete. In other words, it can do any computation that a Turing machine can achieve. So next we're going to actually have a look at running this program and testing that it does in fact calculate the result expected. Here we are in the Delphi 10.4 IDE. I've preloaded the program anonymous method square project. Its type definition is a function type, and we have variable square of this function type, and the anonymous function which squares the input parameter x, and then this is a function application of square to the value 6, and then WriteLine will write it out to the screen. I've already preloaded all the Lesson44 programs. I've set them up in a project group called Lesson44 Anonymous Methods. If I right click on this, all I did was just add existing project to this group. So these are all the programs that I'm going to go through in Lesson44. So without further ado, I'm going to run this program. The console window opens up, and the result of squaring 6 is written to the console window, and it is indeed 36. If I press return, then I will be able to close the window, because this return key will be processed and consumed by readline. If I change this to 4 and run it again, then the function application produces the result 16. And that's the first anonymous method demonstration in Delphi 4 in this Lesson 44 video. Next up, Lesson 44 Part 2, which will cover partial function application. Thank you for listening.